Hi everyone, so here we're going to talk about another type of nuclear reaction, which are fission and fusion reactions. You'll need your notes for this. So these are artificial transmutations, meaning that two particles need to collide with one another in order for this reaction to occur. In natural transmutations, like in the last lesson, they spontaneously decayed, meaning that no energy was needed in order for one particle to break down into smaller particles. So in artificial transmutations, particles can bombard the nucleus of another atom, and mass is converted to energy. Remember that mass is converted to energy because you'll see that question a few times. So the first one is fission. The way I like to remember this is fission is division. Here we have a large nucleus, and it's bombarded by a neutron in order to release into to break down into two smaller particles. So again, a neutron bombards into a large particle and results into two smaller products, and this happens in our nuclear power plants. So if we look here, we have uranium-235. It's being bombarded or hit by a neutron. Then that uranium-235 splits into barium-141 and krypton-92. Those, therefore, split some more, and they will release neutrons. When they release neutrons, they'll actually make more uranium-235 break down. Right? So they'll break down into even further ones. And more neutrons are actually being released by barium and krypton to bombard more uranium-235. So it's a nuclear chain reaction. This one little neutron, by hitting this uranium-235, caused all of these other particles to form and more neutrons to be emitted. So if you look at a nuclear equation for this, you'll end up seeing 235 uranium plus a neutron producing 141 barium and 92 krypton, plus more neutrons. So I'm trying to squeeze in, more neutrons right in there. So that would look like a typical reaction, nuclear equation for this fission reaction. So again, fission is division, it breaks into smaller particles. Fusion, well, if you think about two things fusing, that means that they're combining together. So you have two small particles hitting one another to form another particle. So in this case, you actually have hydrogen, two hydrogens, so a deuterium and a tritium, colliding with one another to form a helium nuclei, some neutrons, and a whole bunch of energy. This occurs in the sun and other stars. So if we want to look at a reaction for this, we have 2,1 hydrogen, or deuterium, plus 3,1 hydrogen, or tritium, producing alpha plus a neutron, let's see if I can squeeze this in, plus a whole bunch of energy. So when they say mass is converted to energy, that means the mass, these particles, are being converted to a whole bunch of energy. Fusion reactions produce a lot more energy than fission reactions. Again, fission occurs here on Earth in nuclear power plants. Fusion occurs in all of our stars. We're trying to do fusion power right now. You'll see scientists, news articles popping up all the time. The problem with us trying to do fusion reactions is that it does take a lot of energy. The reason is that you have these two hydrogen nuclei. They want to repel one another. So right now you're trying to force them together in order to form that helium nucleus. It takes a lot of heat and a lot of energy for this to occur, and both heat and energy are located in our stars. So again, it's pretty difficult to do on the Earth, but it is, scientists are continually working on this as a new source of energy or new source of power. So to summarize, mass is converted to energy. A whole bunch of energy is being released by fission and fusion reactions. Have a good day.